Okay, so now I want to go over section 10.9 about systems of inequalities. So first, let's talk about linear inequality in two variables. It's from linear equations in two variables. If it's an equation, it's ax plus by equals c. If it's an inequality, ax plus by is less than c, greater than c, less or equal. So equation in two variables, inequalities in two variables. Now the question is, how do we find all the solutions? The only way we're going to do this is by graphing. And here's the steps. It's in the handout, in the notes, in the class notes. You're going to see it once you go to class notes on that section. It's there. It's going to be there. So the first thing you want to do, as I'm going through the handout, I'm going to show you an example. So how do we graph 3x minus 2y is less or equal to 6? Find all the solutions using a graph. So you graph the related boundary line. Replace the inequality into equal to find the equation of the so you find the equation of the boundary line, then you graph it. So 3x minus 2y equals 6. To graph it, we need two points. If x is 0, we get negative 2y equals 6, so y is negative 3. If y is 0, we get 3x equals 6, so x equals 2. So we graph that line that goes through 0, negative 3, and 2, 0. A solid line. Why solid? Solid means every point on the line is a solution. Always use solid, just like inequalities. If it's less or equal or greater or equal, and use dotted if it's less than or greater than. Okay, always. Solid means it's every point on the line is a solution. Dotted means every point on the line is not a solution. Identify at least one ordered pair on either side of the boundary line and substitute those values into the inequality. Shade the region that contains the ordered pair that makes the inequality a true statement. All you need is actually one ordered pair. Okay, that's clearly not on the line. So if we pick the easiest one to pick, if it's not on the line, is 0, 0. That's 0. You plug it back into the original inequality. If 0, 0 is a solution of the original inequality, then the whole neighborhood of 0 relative to the line is a solution. If 0, 0 is not a solution, then it'll be the opposite half plane to the line, which would be shaded. So if we plug 0, 0, we get 0, 0 a solution. Yes, it is, because 0 is less than 6. So we shade all the neighborhood of 0, 0 is a solution, and every point on the solid line is a solution. Every point on the non-shaded region is not a solution of the original inequality. Okay, so that's basically it. Now this is linear inequalities. It could be nonlinear, so we follow the same procedure for nonlinear. Like, how do we graph x squared plus y squared is less or equal to 9? So if we graph the boundary, it's not a line, it's a circle. So this is the equation of a circle. Center at 0, 0, and radius r is the square root of 9, which is 3. Remember the equation of a circle, x squared plus y squared equals r squared. It's centered at 0, 0, and radius r. So to find r, you take the square root of that number. So to draw a circle, and we're drawing a solid circle because it's less or equal to radius 3, centered at 0, 0. So this is, instead of a line, we have a circle. That's a boundary circle. Now we're going to check, are we shading inside or outside the circle? We pick a test point, 0, 0. We plug it into the original inequality as usual. It's called test point. 0 squared plus 0 squared is less or equal to 9. Is 0, 0 a solution? Yes, it is. That means everything in the neighborhood of 0, 0 is a solution. Everything outside the circle is not a solution. So that's if we have one inequality. What if we have a system of inequalities? I'm going to write down the steps. So to graph a system of inequalities like 2 or more, you're going to graph and shade twice. Okay, graph and shade each inequality in the system. So you take the first inequality, you draw the boundary curve, and then do a test point, and then you shade and try to use different shades so you can see where the two shades overlap. Highlight the common shade. Like going to the movies. If you go to the movie by yourself, you can pick any movie you want and then watch it. That's your solution set. If you bring a friend along, they have movies they want to watch, you have movie you want to watch. Those are the solutions. You find a common ground to watch, otherwise you're going to split. Otherwise, no solution. So highlight the common sheet. That's called set of feasible solutions. Those are the movies you and your friend can watch. If no common shade, then no solutions. No movie to watch together. If no common shade, no solutions. Okay, 36 page 764. So how do we graph the solution sets for 4x plus 3y is less or equal to 18, 2x plus y is less than 8, and x is greater or equal to 0, y. So there is 4 inequalities. The nice thing about the last two, this tells me nothing is going to be accepted unless it's in the first quadrant. Isn't that what the first quadrant about? It's x greater or equal to 0 and y. So that's my first two inequalities. It shows me that nothing outside this quadrant will be a solution. So that's going to represent these two inequalities. Okay, x is greater or equal to 0, y is greater or equal to 0. So it must. So now we're going to do the other two. 4x plus 3y is less or equal to 18. So we're going to do the boundary line. 4x plus 3y equals 18. It's got to be solid. So make a t-table. X is 0, y is 18 over 3 is 6. If y is 0, x is 18 over 4 or 9 over 2, 4.5. So let me use different colors. 0, 6, 3, 4, 5, 6, and then 4.5, 0, 1, 2, 3, 4, 5, 4.5, 0. Now we're going to shade. We're going to use a test point that's clearly off the line. 0, 0 will always work as long as the line doesn't go through 0, 0. So test point. We're going to plug it always in the original inequality because that's what we're solving. Is less or equal to 18. That's true. It's a solution. So we're going to shade all the neighborhood of the line. That includes 0, 0. But remember, only what's in the first quadrant will be part of the solution set. Okay? And then finally, we have one more. 2x plus y is less than 8. 2x plus y is less than 8. So the boundary line, it's going to be dotted because it's less than. So make a t-chart. X is 0, y is 8. If y is 0, 2x equals 8, x is 4. So let's plot those points. 0, 8, and 4, 0. So this is 6, 7, 8. This is 0, 8, and this is 4, 0. And it's dotted. and we're going to use 0, 0 as a test point because it's clearly offline. So a test point, we plug it all the way there. 2 times 0 plus 0 is less than 8. It's also true, meaning 0 and its neighborhood is a solution relative to the line. So your solution set, it's gonna be everything where the 3 colors are, which is in this quadrilateral. Okay. So any point you pick in this what's called set of feasible solutions is a solution not only to one of them but to all of these inequalities. Everything you pick outside the set of feasible solutions may be a solution for one couple but not all the inequalities. And this is called bounded region. They're asking whether it's bounded or unbounded. Bounded when it's closed, unbounded when it's open. Okay, I'll explain that. I'll show you an unbounded one right now. 42, page 764. 42, page 764. So how do we graph y is greater or equal to x squared, x plus y is greater or equal to 6, and then tell whether the set of feasible solutions is bounded or unbounded. So let's start with y is greater or equal to x squared. So that's a parabola, it's solid. How to graph it? Y equals x squared. So it's gonna go through 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. We know how it looks. It's a U-shaped graph. Just trying to be accurate. Now we're going to use a test point. We may not use 0, 0 because clearly it's on the graph. So I'm going to use, say, 0, 1 right here. So a test point. We're going to plug it in the original inequality. So 1 is greater or equal to 0 squared, which is 0, which is true, meaning all this neighborhood will be a solution. Everything inside the parabola, everything outside will not be a solution of the first one. Let's look at the second one. X plus y is greater or equal to 6. So we do x plus y equals 6, which is solid. Make a t-chart. X is 0, y is 6, y is 0, x is 6. So 0, 1, 2, 3, 4, 5, 6, 0, 6, and then 2, 3, 4, 5, 6, 0. And then we're going to use 0, 0 as a test point. It's clearly off the line, so test point. We're going to plug it into the original one. It's false. 0 is not greater than 6, so we're not going to shade the neighborhood of 0, 0. We're going to shade the opposite. So you can see where the two colors overlap. So this is going to go, it's going to be everywhere in here. And it's not a closed region, it's an open region. That's why it's unbounded. It's not closed in a box. It's open, it goes to infinity, so it's unbounded. That set of feasible solutions. Okay. 56, page 764. 56, page 764. Again, let's graph the solution set of x squared minus y is greater to 0. X plus y is less than 6, x minus y is less than 6. So starting with x squared minus y is greater or equal to 0. X squared minus y equals 0, solid. So y equals x squared. We just did that. The parabola, so let's do that again. Y equals x squared. Go through 0, 0, 1, 1, negative 1, 1. So here's roughly what the graph looks like. And then we're going to do a test point. Again, we're going to do 0, 1. Test point, 0, 1. Plug it in here. 0 squared minus 1 is greater or equal to 0. It's false. So the shading is going to be outside. So everything in this neighborhood, neck of wood, is a solution to the first inequality. Okay. Let's see what the second inequality looks like. X plus y is less than 6. We use different color pen. So it's going to be a dotted line. X is 0, y is 6, y is 0, x is 6. So 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6, 0, and 0, 6. Again, we can use 0, 0 as a test point. It's clearly off the line. A test point. I'm going to plug it in here. 0 plus 0 is less than 6. It's a solution. It's true. So we're going to shade the neighborhood of 0, 0 relative to the line. There is 0, 0. There is the line. So everything in here is a solution of the second inequality. So you can see where the two colors merge now. Now let's see what the third color is going to bring us. I'm going to use green. So x minus y is less than 6. So we do the boundary line, which is dotted. I'm sorry, that second one should have been dotted. Yeah, I made a mistake. So this should have been dotted, okay? Make sure you dot that. The points on the line are not solutions. So x is 0, you divide by negative 1, y is negative 6, y is 0, you get x is 6. So 0, negative 6, and 6, 0. 1, 2, 3, 4, 5, 6. This is 6, 0, dotted line. Now we're going to do a test point. Again, 0, 0, right there. 0 minus 0, it's true. So everything in this neck of wood is a solution. And you can see where the three colors overlap in that neck of the wood. Anything in that set is a solution of all inequalities. Okay. And that ends 10.9 until 10.10. Have a good one.